Hello viewers, as you can see the question says magnesium reacts with chlorine to form the ionic compound magnesium chloride. A part, draw a dot and cross diagram to show the bonding in magnesium chloride. You only need to draw outer valence electrons of magnesium and chlorine. B part, the physical properties of compound related to its structure and bonding. Magnesium chloride has an ionic lattice suggest two physical properties of magnesium chloride. Now the answer for the A part is, you can see I have drawn two ions, magnesium on the right top corner, two positive I have written the charge, and two chloride ions on the top I have written one negative charge. Dot is for electrons for magnesium and cross are the electrons for chlorine. You can see I have written on right side magnesium, its electronic configuration 2, 8, 2, chlorine, its electronic configuration 2, 8 and 7. Now when magnesium, it is going to lose its 2 electrons and its inner shell is complete, and chlorine is going to gain 1 electron and it's also the valence shell is, outer shell is complete. Now we are not drawing the valence electrons because magnesium valence shell is empty now, so we need not draw that shell. So we are going to draw the inner shell. Now the physical properties, as you know, we have discussed physical properties in our states of matter. Physical properties regarding their structures, their melting points, their boiling points, their solubility, their conductivity of electricity. So its physical properties: high melting point and boiling point. Number 2, soluble in water or able to conduct electricity when molten or in aqueous solution. So this was your question number 1. If you have any problem in understanding these concepts, you may go to my lecture of ionic bonding and covalent bonding. Now I come to question number 2. Now question number 2, as you can see, is there is a diagram drawn of metallic structure and its graph. Question says the metal tungsten, its symbol W, is used to make wire filaments in light bulbs. The wire glows when electricity passes through it. Now you must have seen the bulbs, the older bulbs. Nowadays we do not use such kind of bulbs, but they are there and you can examine the bulb and you can see the tungsten wire in it. And it glows when electricity passes through it. Now this is the structure of typical metal. You can see, and I have already discussed the definition of metals. Positive ions and the negative ions are showing the electrons in between them. Now when the potential difference is applied, these electrons, they start moving and the metal starts conducting electricity. Part A, it asks, use this structure to explain how tungsten conducts electricity. Part B suggests two other physical properties of tungsten, and C is the graph which I am going to discuss along with its answer. Now A part, the solution: tungsten metal has a sea of delocalized electrons surrounding a regularly arranged positive metal ions in the metal lattice. The delocalized electrons conduct electricity by flowing in the direction of the potential difference applied. B part is tungsten is ductile and is a good conductor of electricity or heat. Now next, third part. Now it says, you can see the graph over here, and the graph is, as we have already discussed in states of matter, heating and boiling curves, cooling curves. You can see this is a heating curve. Its temperature is rising from 3000 till 7000, and you can see actually it is from 0 to 7000. So the graph says you can see there are two levels, and as we have already discussed in our states of matter topic, first of all is it is melting over here, that is at almost 3400 degrees centigrade, and then at 5600 degrees centigrade it is again the graph is leveling out, which means now again change of state is taking place. So this is that is from liquid to steam. This is the boiling point. Now the question says, in a light bulb, the tungsten wire may get so hot that it melts and breaks. This graph shows the heating curve of tungsten. Now, it means that the tungsten wire is in the solid state, and at a certain temperature it starts melting. So the first level where the graph is leveled, this means state of change is taking place. That is, from solid it is changing to liquid, and this temperature is 3400 degrees centigrade, or you can say 3400. So this is the melting point, and then temperature is rising again, and at 5600 degrees centigrade it's again leveling out. This means state of change is taking place. That is, it is changing from liquid to steam. So this is its boiling point, that is 5600 degrees centigrade. Now I hope you have understood this concept and this question also, and you must go back to my lectures where I have explained metallic bonding and where I have explained this heating and cooling curves. So you first revise those and then solve the questions. Now I come to question number 3. It says diamond and graphite are allotropes of carbon. They are both composed of macromolecules. I will repeat again that I have taught you about allotropes and macromolecules, structure of diamond and graphite in bonding chapter. A part, explain the meaning of the terms number 1, allotropes, number 2, macromolecules. Allotropes are different forms of same element in the same physical state. Now you can see that diamond and graphite, they are both made up of carbon and they are both in the solid state, but they are different forms. Now macromolecule, it is a giant molecule with a 3-dimensional structure or a layered structure consisting of a network of covalently bonded atoms. Now the B part, explain in terms of graphite structure why it acts as lubricant. Now as you can see the structure, you can see the layers, and I've already explained that between the two layers there are delocalized electrons and the layers can slide over each other. So we are going to use this property of graphite for its use. The carbon atoms are arranged in layers. They have weak forces of attraction in between layers, so they can slide over each other easily when rubbed. Now I come to question number 4. Chlorine forms some compounds that are covalent and others that are ionic. This is just an information given. Now the A part, draw a dot and cross diagram to form carbon tetrachloride. Tetra means 4. You need to draw the outer electrons of carbon and chlorine atoms. Now you see, I have been mentioning before also, that is, In your question, they will tell you whether to draw only valence electrons, and if they have not, if they do not say that valence electron or the outer electron, then you can draw all of the shells. Now, in order to solve this question, you should know back of your mind, which I have written on the side in a margin, that is carbon and chlorine both are non-metal, so will form covalent compounds. First of all, you have to decide whether chlorine and carbon, they are going to form ionic or covalent. So as both are non-metals, so they will form covalent compounds. Next, you should know the atomic number of carbon and chlorine. Carbon is atomic number is 6, so its configuration is 2 and 4. Chlorine atomic number is 17, so its configuration comes out to be 2, 8 and 7. So one carbon it needs 4 electrons to complete its octet. Now carbon is going to share 1 electron each with chlorine. So they are going to be 4 chlorine, and there are going to be 4 pairs shared among carbon and chlorine, 1 pair each with 1 chlorine. Now the B part, draw diagrams to show the electronic structures and charges of both ions present in calcium chloride. Now here again, you must, in your back of the mind, you should know the atomic number of calcium and of chlorine, their electronic configuration, which I have given you on the right hand side. Calcium 2882, its atomic number is 20. Chlorine, its atomic number is 17, so its configuration comes out to be 2, 8 and 7. Calcium will lose its 2 valence electron because the inner shell is complete, so its configuration comes out to be 2, 8, 8, and the calcium will have 2 positive charge. Chloride negative will become chloride 1 negative charge on it by gaining 1 electron, 2, 8 and 8. So they are going to be 1 calcium and 2 chloride ions to balance the positive and negative charges. Now there is question number 5. It says draw dot and cross diagram for carbon dioxide. Here again, you should know that carbon has 4 electrons in its valence shell, oxygen has 6 electrons in its valence shell, and both are non-metals, so they are going to form covalent compound, and carbon is going to share 2 electrons with 1 oxygen and 2 electrons with another oxygen, forming double bonds. Fluorine atom, the B part, fluorine reacts with magnesium to form magnesium fluoride. Number 1 part says, write a balanced equation for this reaction. Now we have done this again in our ionic bonding and covalent bonding chapter. Magnesium plus fluorine forms magnesium fluoride. Now there is one thing you must remember, that if fluorine in nature will exist as F2 diatomic molecule, magnesium, all metals, they exist as monoatomic form, they do not form molecules. Number 2, give both the electronic configuration and the charge on the ions which are present in magnesium fluoride. So, first of all, you need to remember their atomic numbers, which I have given on the right side just for your ease. Fluorine atomic number is 9, its configuration 2, 7. So when it gains 1 electron, it becomes a negative charge 2 and 8. Magnesium atomic number 12, 2, 8 and 2, its electronic configuration. When it loses 2 electron, it becomes magnesium 2 positive. So one magnesium is going to lose 2 electrons, and one fluorine each is going to gain 1 electron. Now I hope you will be able to solve your questions in your exams easily. So please like my channel, subscribe my channel,